to just write out a couple of, any questions about that? I'll show it again. I just want to write out a couple of the steps. So enzyme lysine NH plus, here's the shift base. So this is PLP. Okay? And so this is the shift base, and this is also called, as I mentioned, the internal albumin. And then we have an amino acid coming up here. And so we have some L-amino acid substrate. And so this, so a proton gets taken off of here, or else it dissociates before it even binds, because it's alpha amino. And then this attacks here. And so this is just a displacement. Right? So remember, the first thing is we start with the enzyme in a PLP bound form with enzyme PLP linked through a shift base, but we need to bind substrate. And so the way the substrate binds, it doesn't just bind non-covalently, it binds in a reaction to displace the enzyme lysine that was a covalent bond, right? So this is a covalent bond between the whole enzyme and the cofactor PLP. And so now here's your substrate coming in and displacing that. Right? So this is just going to form whatever the amino acid is here. You got that positive charge down here. Okay. So now this is the external albumin. Okay. Any questions about that? So this is therefore then releasing free enzyme in the sense it's apoenzyme, enzyme without the PLP bound. Okay.
Does the reverse happen to regenerate the enzyme?
Yeah, the enzyme regeneration can go by going the other way. Yeah. Yeah, so these reactions are all reversible, and the overall delta G's between going from alpha amino to alpha keto are usually around 0. So it's not like the overall reaction is energy, energy yielding or energy consuming.
So,
yeah.
does that mean the free enzyme is in its offset naturally?
I'm sorry?
Does that mean that the free enzyme is inactive initially until?
Yeah, no, free enzyme doesn't work until it starts out with a linkage through PLP, and then that gets displaced. Yeah, so PLP is made in the cell by some secondary metabolism pathway, and then it has binding determinants for whatever enzymes it's supposed to go onto. It goes on there, and that shift base forms. Right, it's like aldolase does, except in this case, it's forming a cofactor enzyme covalent complex that's ready for a substrate, and it's doing that on 100 enzymes in the cell that are all PLP enzymes. Okay, so we start from there and say, okay, what happens next? And so if we have this amino acid on here, to make sure I draw this right. We have a base come in here. Right, so we're going to be able to do this. Okay. So the bond that we're breaking is here. Right, and as we break that bond and pull this proton off, what's going to transiently form is a carbanion. Right? So what transiently forms from this looks like this. it says the proton is gone, the carbanion is left. But now we can take this and stabilize it down to here. Right?
There's a double bond missing between the alcohol and the methyl group on the ring, I think.
Right there?
Yeah, I think so.
So this will form this quinonoid. And then this can go, you can add water back to it, which is the reaction we're talking about today, to form the alpha-keto acid. When we add water, when we form the alpha-keto acid, this will form pyridoxamine PLP. And then these other, there's a racemization reaction can get promoted from the initial amino acid that got attached. You can decarboxylate the amino acid to form an amine. Those are just other possibilities that we're not concerned with now. Okay. But when we get to here, that this carbanion is stabilized through here, if water attacks here, right, this comes off, right, and then we have CH, NH2, okay, when we add water in through here. And that is the amine form. Okay.
So does that become an aldehyde and an amine between those two groups?
This goes off to form the alpha-keto acid when you add water across this bond.
Mm-hmm.
So when we add water across this bond, the oxygen of the water will end up here to form an alpha-keto acid. Here's the acid and whatever the skeleton is. And then this will turn into NH2, and that's the pyridoxamine, and then that will be half the reaction. Right? We will have released the amino acid, right? We'll have released the alpha-keto acid coming off the top of that because we bound an amino acid to start. We bound an amino acid, we displaced the enzyme lysine, we formed an external aldamine with the incoming amino acid. We used the enzyme chemistry to pick off, break a carbon-hydrogen bond, stabilize this quinonoid intermediate through the carbanion, and then water attacks that, and an alpha-keto acid comes off where the amino acid used to be. So this R group is whatever the amino acid was. So if it was alanine, that's just a methyl group, you just formed pyruvate. Yeah?
So you showed the free enzyme early on. That doesn't mean this thing is released in the cytosol.
On the previous step,
Yeah, right.
I just meant to say that,
It's no longer clear now.
yeah, it's no longer, I mean, it's,
So it's still
well, it's, what,
stabilized.
yeah, I didn't mean it was coming on, that's probably,
So it's still in the active site. It's
yeah,
stabilized.
yeah, it's just that, I shouldn't say that. So I could say, enzyme no longer covalently linked. It's just to indicate that the PLP part is now linked to the amino acid rather than the enzyme lysine. Okay, so, questions? I could write out the last step as well, but I think maybe it's okay to skip it. That's about as much as we really need to see, I think. Other questions? Okay, so glutamate dehydrogenase. So now we can go back to here. So the transaminase reaction is collecting amino groups in the form of glutamate. And the next step is to split off ammonium from glutamate in a glutamate dehydrogenase reaction. And so if we take a transaminase reaction and then the glutamate dehydrogenase reaction, which is an oxidative deamination reaction. Here's the ammonium coming off. So this is an oxidative deamination reaction because this carbon here is oxidizing to here. And at the same time, we're generating a reduced cofactor. Okay, so glutamate dehydrogenase, which is, you could think of it really as the first committed step in this pathway, or a really specific step to get rid of the ammonia, because before that we're just kind of collecting things in the form of glutamate. But we've still got amino acids. We imported amino acids from other tissues. We've got some coming from dietary breakdown and from specific reactions in other tissues like muscle. But now we're gonna start to get rid of those amino groups, and the reaction is this one. It's an oxidative deamination by which glutamate is converted to alpha-ketoglutarate, and with the release of ammonia, formation of a reduced cofactor,